Hello everyone, in this video we'll see longest increasing subsequence problem. This is a competitive programming problem and this is a very famous interview question also. So we quickly jump into the what's the LIS stands for and coding also. So what's this longest increasing subsequence? So the longest, here is a sequence. You have 10, 20, 30, 40 and 20 and 60. So this is a sequence. In this sequence we are going to find out a subsequence. Subsequence means a subset of this long sequence. So here you can notice this 10, 20, 30, 40, 60. This numbers are increasing. This is a numerical array and these numbers are increasing order. So in this array, this is the longest increasing sequence. So there is one more sequence also in this one. You can see this 20 and 60. This is also increasing. 10, 20, 60. This is a increasing sequence. But that's the output is 3, but the longest is the answer will be 5. So that's the number you are going to print as answer as 5. You're not going to print the actual numbers, you're just going to print this 5. So the answer will be 5. So which are all the, this is the answer, 10, 20, 30, 40 and 60. So my problem solving approach for solving this question is called dynamic programming. So this is one of the famous problem solving approach. You might heard of it. About 4 problem solving approaches. This is the one of the tricky part to do in programming. Okay. Here I am going to use a tabular method. It's not a table, it's just an 1D array, and we are going to, how do we fill this? So in order to use the dynamic programming, you have to understand the subset of problem. This problem is a big problem, but here you can take this first 2 values. By solving this small portion of this problem, you can lead to a solution for the whole problem. So that's the thing called subset problems, and by solving this subset problem, that will lead to the actual solution. Okay, I have this 10, 20 and 30. I'm going to just solve this 3 and I'm using this solution for my bigger solution, which means 10 to 60. So what I need to do is, I have one array called LIS. This is that array. And what's this table is actually is, this is a one-dimensional array. This is not a 2D array. This is for just illustration purpose. I've drawn as a table method. But each line is a state, each row is a state of this LIS array. So you're iterating it as inside 2 for loops. That's the reason it is like 2-dimensional array. But it is not a 2D array. This is a state. This one is a row stands for a state. Okay, now what I do is, I have the position as I equal to 0, and when I equal to 0 means I have only this number 10. So when I have this only one number 10, there is nothing increasing or decreasing, so the output of this is directly 1. So instead of declaring as an output, I am initializing this value of LIS 0 to 1. So when I have this only value 10, my answer will be 1. I am taking this solution further for solving the whole problem. So in next iteration, which means I am starting from this state as I equal to 1. So initially my value is 1. Here this previous state I'm directly copying here, so 1. Okay, now here we move to the next one. Here there's initial state also, it's 1. This one is previously what output was. I'm just pasting here, and this is 1. The current one is 1. So by standing in this cell, I'm going to compare all the previous cells against this current value. And if it is this value, which means the where I'm standing, this value is higher, and here I have lower value, which means here you can see this 10 and here is 20. 10 is lesser than this 20. In that condition, and the value of this LIS array plus 1 is greater than the current value, then I'm updating the array, which means I have written this condition here. It's literally when the actual where I'm standing is, it's j, this is I, which means this cell is for, I'm pointing this cell as array of I, and all those previous cells are for j. So j means from beginning to prior to this cell, I'm iterating all those values, and I'm comparing those values against my current number, this 20, and this LIS value also. So the LIS value of I is nothing but this cell, and this Li of j is these previous cells. Here this cell is the array value, here this cell is LIS value. Actually this table is for LIS value. The array value will have in the some other array, which means the here I have written. So this LIS of j is previous values. When this condition is true, which means there is an actually increasing order, then I'm checking for this condition LIS of I, which means here, and LIS of j plus 1, from here plus 1, is it increasing? If that's the case, I'm incrementing this value. So we just clear this. Here I am standing here at 10 and comparing with 20. Yes, it is increasing. So I'm comparing this value 1 plus 1. So my answer is here 2. So in this example, even you can see this. When I have this, you can just stop this problem until this 10, 20. Here you can see this 1 and 2, which means the increasing sequence of this LIS array. 10 and 20, therefore the answer is 2, because I have 10 and 20, both are increasing. So the answer is 2. By solving this small subset, I am going to solve the whole problem. So we directly write that previous status 1 and 2. It's okay. Now I am standing at 30. I initialize to 1, and I am comparing this value of this value to all those previous values. So 10 and 30, is it increasing? 10 is lesser than 30, yes, so it is an increasing one, and I'm taking this value 1 plus 1, so because it is increasing. So 1 plus 1, 2. Is it greater than my current cell? Yes, it is greater, so I update it as 2. So okay, now I move to 20. Now I move to 20 and checking this value, is it greater? 20 and 30, 30 is greater. So what I'm doing is I'm checking this LIS array value plus 1. So it is 30. So this answer is literally when I have 10, 20 and 30. So it's steadily increasing and the answer will be 3. Okay, now I'm taking this same previous output state. This is all are updated in one-dimensional array, LIS one-dimensional array. So here I'm initializing for 40, it is 1, and I'm checking this value 10 and 40. Yeah, it is correct, because this condition is satisfied. And the next condition is LIS of I and j, here 1, so 1 plus 1, so 2. So it is greater, yes, it is greater. And next 20 and 40, yeah, this condition is true, which means 20 is lesser and 40 is higher. So yes, and 2 plus 1, here it is 3. And next condition 30 and 40, yeah, it is true. So 3 plus 1, 4. So I'm updating as 4. Okay, now I'm just copy the same previous state. Okay, when I have 20, I initialize to 1 and I'm checking 20 from the beginning. 10, is it lesser than 20? Yeah, it is lesser. So 10 is lesser and 20 is higher. So 1 plus 1, so it is 2. And next 20 I'm checking. This condition is incorrect because it is equal. So we have to take only the greater. So we can skip it. So the 2 will be there. When I'm checking with this one, no. Then I'm checking this one also, no. So it is ended. So the same state for next iteration is 1, 2, 3 and 4 and okay. Now I initialize this last one to 1. From the beginning I'm checking here from 10 and 60. Comparing this, yes, 10 is lesser and 60 is higher. So 1 plus 1, 2. Next case 2, the same thing. So it is 3. Next 30 and this one, yeah, 4. And next this one and this one, so it's 5. And this one and this one, it is greater, but when you see this condition, LIS of here already I have 5. Even though I add this 1 also, it is 3, so it is very less. So it is 5. So this is no need to update. So it's already 5, which is the LIS value is bigger already. So I can skip this. So after filling this, traveling all these conditions, you have to find out which is the maximum in this. So 5 is the maximum. So my answer is 5. So we quickly jump to the Visual Studio Code and we'll see how do we write the programming for this in C++. Now open Visual Studio. I need an array, so int arr. I'm just declaring it as 100 elements and initializing it to 0. And I need n, so n, and I need LIS array, so LIS, that's also I'm declaring it as 100 and initializing it to 0. Cin of n and in for int n cin arr. I have to initialize the first one to 0, 0 to 1. In filling this, int n for int j to I. Before I have to, here it is 1, and if the condition arr of I is greater than arr of j, double and LIS of I, LIS of j plus 1. If that is the case, LIS of I equals LIS of j plus 1. For that I have to initialize as LIS of I equal to 1 and see out how to find the maximum element of this. So max element of LIS comma LIS plus n. Okay, and here we're declaring the array and number of elements and LIS array for this programming, dynamic programming. in first line you get the scene of a number of elements, and you assign that it in one array, and I'm initializing it as LIS of 0 is equal to 1. The first step here we did, when nothing is there, only one element is there in this, we have to initialize it to 1. So that's done in this one. And from this to here, we first initialize it as 1, and then only we update it. So here this line is for that, and we are iterating to each previous elements. So this for loop is for this, that's the reason, and we are ending it before this current element, and here in this line we are checking the array of I, which is this element, and comparing all those previous elements. So this line is for this. Those two conditions are written here, and these two conditions are written here. In that case, we have to assign that LIS of I equal to LIS of G plus 1, and this is a built-in function to find out what's the bigger element, what's the greatest element in this array. So LIS of, I'm starting the first begin iterator and ending of this iterator. So LIS of LIS comma LIS plus n, and returning those pointers, and I'm printing the content by using start operator. Okay, now we'll format the code and run this, and we'll see the output. I'll copy my test data, copy. Here you can see this, this is the same as our demo. Answer should be fine. Now run the code, run. Paste, and our answer is 5. Okay, and I have one more test case. Here it is steadily decreasing order, so there is no increasing order, so the answer should be 1. Run again, paste, so the answer is 1. So hope you understood the problem and solution, where how the subset is we can solve, and how it leads to the actual solution. So this is O of n square algorithm. So here you have number 2 for loops. So there is a better algorithm is there in this one itself, solving the problem in n log n time. So that's the best algorithm, but this is a very easiest method for solving this LIS problem in n square time. So hope you understood this problem and solution. Thanks for watching this video. We'll meet in the next video.